So in the first part of this algebra review, what we're going to look at here is some different things involving some properties with square roots, and we're going to look at some different things with square roots involving multiplication, as well as addition, subtraction, and some different things with division. So for this part A, we have here the square root of 5 times the square root of 6. So one of the things to keep in mind when you're looking at square roots is some of the different properties that are involved with square roots is very similar to some of the different things that we know about properties involving variables. So for instance, if we were going to do something like this, x times y, we would say that x times y, or a shorter way of saying xy, x times y is xy. Well, if we were going to do the square root of 5 times the square root of 6, a similar sort of thing happens here with this, in that I can take the square root of 5 times the square root of 6, and I can shorten it to just be the square root of 30. So even though what's inside the values inside the square roots are different, I can still multiply those together and include it as one simple square root, just like we could do here when we were multiplying two variables that were not the same. So for part B, when I have the square root of 7 times the square root of 7, I'm going to do the same thing here. I'm going to say the square root of 7 times the square root of 7, 7 times 7 is 49, so this would be the square root of 49. And then since the square root of 49, we're looking to simplify here, since the square root of 49 can be simplified to just be 7, that's what I would want to simplify that down to be there. So that's part B. For part C, I have some different things here with division. So I have the square root of 9 over 64. And one of the things that I'm going to do with this before I start to simplify the square root part of this is I'm going to break this up into two square roots, meaning I'm going to take the square root of 9 over 64 and I'm going to make this the square root of 9 over the square root of 64. And from here I'm just going to simplify each square root. So I would say the square root of 9 is 3, square root of 64 is 8, so that would simplify to just be 3/8. And then with part D, I'm going to do the same thing that we just did in part C, but I'm going to do it in reverse, in that with part C we took one big square root and made it two separate square roots. With part D, I'm going to do the exact opposite, in that I'm going to take two separate square roots and I'm going to write this as one big square root. And I'm going to do that because if I do 12 divided by 3, that ends up being 4, and then the square root of 4 would equal 2. Now that's not the only way to do part D, but that is definitely what I would say is the simplest way to do part D. So one of the things I wanted to show you before we move on, and I'll kind of use part A as my sort of basis for my example here. So when we did the square root of 5 times the square root of 6 and we got the square root of 30, one of the things that we always ask ourselves with something like this is, what are some different things that we can do to see if this is right? So if you take your calculator and you put in the question, or type in the question, so I'm going to have here the square root of 5, just use your right arrow key to get out of the square root, times the square root of 6. So I have this here. I get an answer to that, and then if I type in the square root of 30, what should be true here is this same decimal answer that I got when I did the square root of 5 times the square root of 6 is the same decimal answer that I should get when I do the square root of 30, which you can see here occurs. So that's just something that you can always do with the square root problems whenever you're simplifying. You can always use your calculator to just type in what the question says and then type in the answer and see that you get the same the results. So moving on to some other things with square roots. Now this just involves some different things with square roots involving simplification. And there's a lot of different ways that you can simplify a square root. One of the easier ways to do this is to think of numbers that you can divide into a square root, that when you take the square root of that number, the value of that works out evenly. And those numbers are referred to as perfect squares. So going through some of the different perfect squares that there are, and like I said, perfect squares are numbers that you can take the square root of evenly. So we would have 4 as a perfect square because the square root of 4 is 2, and then we would have 9 as a perfect square because the square root of 9 is 3. 16 is a perfect square because the square root of 16 is 4, and 25, and just kind of listen some others, 36, 49, 64, 81, and 100 are some others. And one of the things that I'm looking at here when I go to do this is, what is the biggest perfect square that I can divide into the number that's inside the square root? So if you take a look at the square root of 18, I can break this up to be the square root of 9 times the square root of 2. Because from what we did previously here, in the first example, we know that I can take two different square roots and multiply them together to be one number. Well, I can do the same thing, but in reverse here. I can take one square root and I could break it out into two separate numbers here. And the reason I'm choosing 9 and 2 and not 6 and 3 or something else is because the square root of 9 works out evenly to be 3, and then the square root of 2, because that doesn't work out evenly, I'm going to leave that as the square root of 2. So we would say the square root of 18 simplifies to be 3 times the square root of 2. So moving on to part B, and I'm going to leave these perfect squares here because I'm going to need those for some of these other examples in this part here. So with the square root of 32, once again I'm looking for what's the biggest perfect square that can divide into 32. So if you notice here, there's a couple different perfect squares that do go into 32. 4 goes into 32. However, 4 is not the biggest perfect square that goes into 32. 16 is the biggest perfect square. So when simplifying here, just like when you're simplifying fractions, you always want the biggest number that can divide into both the numerator and denominator. Well, the same concept applies when we're talking about simplifying square roots. So I'm going to break this up and I'm going to make this the square root of 16 times the square root of 2. So when I go to do the square root of 16, the square root of 16 is 4. Square root of 2, that doesn't work out evenly, so I leave that as square root of 2. So the square root of 32 simplifies to be 4 times the square root of 2. So that's part B. For part C, just want to erase and get some room here. If you notice with this, I have the square root of 9 times the square root of 27. So there's a couple different ways you could do this. You could multiply both of these together and make it one big square root and simplify it that way. However, if you notice here, the square root of 9, I already know what the square root of 9 is. That's 3. So I'm going to leave that off to the side, and I'm going to simplify the square root of 27. So the square root of 27, I can break that down to be the square root of 9 times the square root of 3. So once again, square root of 9 is 3, and then the square root of 3 just stays like that there. But then if you notice, I want to multiply this 3 here to the result that I got here, and when I do that, I'm going to multiply this 3 here to this 3 here, because those are both values that are outside the square root, and that's going to make this 9 times the square root of 3, and that's what that would simplify to be there. And then for part D, even though I have two fractions here, I'm still going to go about this the same way as we did before. So I have this here, square root of 4/5 times the square root of 3/5. And what I can do here is I can multiply these two values together, the 4/5 and 3/5, and when I do that, I end up with the square root of 12 over 25. So if I break that apart to be the square root of 12 over the square root of 25, well, you can see here with the denominator, square root of 25 ends up being 5, so that just stays like that there. However, the square root of 12, and I'm going to sort of do this off to the side here, the square root of 12 can be simplified. I can break this up to be the square root of 4 times the square root of 3. So the square root of 4 is 2, and then the square root of 3 would just stay the square root of 3. So I would have that on the top here, 2 times the square root of 3. So you'd end up with something like that for the numerator. So the answer to this would be 2 square root of 3 over 5. So that's some different things with simplifying square roots in regards to taking square roots and simplifying, as well as some different things that we talked about in the previous example with some different things with multiplication and division. Some other things we can do with square roots, and this has to do with adding. So as I mentioned to you at the beginning, there's a lot of similarities in terms of properties of square roots that we have in terms of properties with variables. So for instance, if we had 2x plus 3x, we could put those together and that would equal 5x, because we can add the coefficients of those when the variables are the same. Well, the same is true involving square roots. So for instance, if I had 5 square root of 3 plus 7 square root of 3, think of the square root part here as the variable. So this would be like 5x plus 7x, which is 12x. But instead of it being an x, it's a square root. So when I do 5 square root of 3 plus 7 square root of 3, 5 plus 7 is 12, so this would be 12 square root of 3. So that's how you do some different things with adding. Subtracting, same thing. So I have here 5 square root of 3 minus 7 square root of 3. So I'm going to do the same thing here. I'm going to subtract these values that are in front of the square roots. 5 minus 7 would be negative 2, so the result of this would be negative 2 square root of 3. So you'd have something like that for part B. For part C, notice that I'm back to adding again, but notice that the values inside the square roots are different. So just like when you're trying to add and say a 2x to a 3y, the answer to that would just be 2x plus 3y. Well, the same is true with square roots. Whenever the values inside the square roots are different, you can't add those together either. However, if you notice with this second part, there's some simplifying that can be done with this. So if I have this 2 root 3 plus the square root of 27, I'm going to take the square root of 27 and kind of put this off to the side here. So the square root of 27, I can break that down to be square root of 9 times the square root of 3, and when I simplify that, this ends up being 3 square root of 3. So if I take the square root of 27 and put this in its place, right, so I have the 2 root 3 in the front, now the square root of 27, I'm going to make it 3 root 3. So you can see here that now I do have two square roots that I can add together because the square root parts are both the same here. So 2 plus 3 is 5, so this ends up being 5 square root of 3. So just because the square roots are different, don't just assume that there can't be any adding or subtracting that could be done. Always take a look and see if any of the square roots can be simplified first before you say that there's no adding or subtracting that could be done there. And then for part D, same sort of thing as I have with part C. I got two different square roots here, and notice the numbers inside them are different. So at face value you would say I can't add those together, but however, if you take the square root of 98 and I break that down to be the square root of 49 times the square root of 2, this ends up simplifying to be 7 root 2. And if you take the square root of 50, I'm going to do the same thing. This ends up being the square root of 25 times the square root of 2. And the square root of 25 would be 5, so this ends up being 5 root 2. And I'm going to add these two together. And when I do that, 7 plus 5 is 12, so this ends up being 12 square root of 2. So once again, here's another square root problem where initially what's underneath the square roots are different, but when you simplify the square roots, you'll notice that you'll end up with two square roots that can be added together. And then finally, some different things involving multiplication with square roots. So when I'm talking about multiplying with square roots, just keep in mind the same sort of thing that we talked about with properties of square roots, very similar to some different things with properties of variables. So for instance, if I had 3x squared times 4x cubed, okay, what I would do here is I would multiply the coefficients. So this would be 3 times 4 is 12, and then I would multiply the two variable parts here. X squared times x cubed is x, in this case x to the 5th. So I'm going to do the same thing here that I did with variables. I'm going to do the same thing with square roots. I'm going to multiply together the parts that are the same. So here I got 3 root 2 times 4 root 3. So what I'm going to do first is I'm going to multiply the numbers in front of the square roots. 3 times 4 is 12. Then I'm going to multiply the parts that are inside the square roots. 2 times 3 is 6. So when I multiply 3 root 2 times 4 root 3, the answer to that, or the simplified version of that, would be 12 root 6. So that's some different things for part A. For part B, I have 3 root 2 times 5 root 2, and I'm going to do the same thing here. I'm going to multiply the parts that are the same. So first I have these numbers that are in front of the variables. 3 times 5 is 15, and then I have the parts inside the square roots. 2 times 2 would be 4. Now if you notice what's inside the square root of 4 can be simplified. So I want to once again take what's in here and I want to simplify this. The square root of 4 is 2. So remember that in between the 15 and the square root is a multiplication sign. Right, so 15 times 2 would be 30. And that's the answer for part B. And then for part C, I got the same sort of thing. Here I got 4 root 5 times 6 root 10. So same sort of thing here in that I'm going to multiply together the parts that are the same. So I'm going to take first these numbers that are outside the square roots. 4 times 6 is 24. and then I have what's inside the square roots. 5 times 10 is 50. So if you notice here, the square root of 50, that can be simplified. So if I take this off to the side, the biggest perfect square that goes into 50 is 25. So I can take the square root of 50 and make this the square root of 25 times the square root of 2, which then I can simplify to be 5 root 2. So I want to take a square root of 50 and I want to change that to 5 root 2. So just once again, keep in mind, in between the 24 and the square root is a multiplication sign. So what this really ends up being is 24 times, instead of the square root of 50, I'm going to say 5 root 2. So when I go to multiply these, 24 times 5 is 120 square root of 2. And that's the answer for part C. So that's just some different things that you need to be aware of involving square roots in regards to some different things with adding, some different things with subtracting, some different things with also involving multiplication and division, as well as some different things with simplifying and reducing. The next part of our algebra review, we're going to look at two things. One is we're going to look at some different things involving laws of exponents, as well as some different things involving variables and combining like terms.